So primarily, according to what they say, is if you were to fly to a comet, you should primarily find ice. You know, when you get there, you crash something into it, you should ice and water vapor should come off.
And where do they say this ice came from?
Well, they say this ice came from the Oort cloud, because there was a cloud of material left over from when the solar system was formed, and that just contains leftover bits of dust and water, which is hydrogen and oxygen combined. Right. That's the standard sort of model. Right. And you obviously you're going to, or according to them, you're going to get things stuck into the snowball, which are just other bits of rock, bits of compounds that formed when the solar system was formed from the whatever process formed it. They get lodged into the surface of the snowball. That gets carried into the solar system when the comet comes around, and so by watching the comet melt, looking at that material, you should be able to tell what sort of materials were there, according to them, in the early solar system. Right. Okay. So the basic thing we're trying to get to, I suppose, is that it is assumed right down the line that the only thing that comets are a result of is a formation of the solar system, right? So that's the kind of idea they want to keep you fixed on. Right. We don't want this idea that comets come from somewhere else, or they're formed by some other process which has little or nothing to do with the formation of the solar system. Right.
So is it suggesting that we had planets formed, and then maybe there was a massive collision which created loads of little bits, and they are comets? So comets maybe used to be part of a planet. Is that what it's suggesting?
Well, they're not suggesting that. NASA and the mainstream astronomers are not suggesting that. Right. It's several groups of people. One group is the David Tolbert and Wallace Thornhill, who've been working on the electric universe model since about probably for 10 or 15 years now. I first became aware of it in 2004. So they would contend that you can't say for sure that the comets are from the early solar system. They're not a result of leftovers of the early solar system. They think that at least a number of the comets, not necessarily all of them, are formed as a result of the breakup or partial breakup of planets in the solar system.
Right. All right. Now, just to come on to the electric theory of comets and the universe, let me just, because this is fairly new to me, some of the data that come back from these probes is suggesting that the comets have an electrical charge.
Right.
Just expand on that.
Right. So with standard astronomy, the solar system is electrically neutral. There's no overall charge, within the solar system. And there are no particular electrical interactions between the sun and the planets. It just doesn't happen. It's just all we have is basically heat exchange. We get heat from the sun, ultraviolet radiation, and so on. You get the odd bit of phosphorescence, like the aurora borealis, for example, is allegedly a kind of phosphorescence.
Right. And other than that, they're obeying Newton's laws of gravity, not motion.
Yeah, and so the solar system is driven by gravitational force, or that's been sort of morphed into relativity, which is slightly different. But essentially, gravitation still explains the motion of the planets in the solar system.
Describes, I would say.
Yeah.
Not explains.
Yeah, describes. That's probably a better word. So the idea that the electrical charge plays any significant role in the way that the solar system works, or in the solar system, or in the processes that go on in the solar system, that's generally regarded as just a sort of fringe theory.
Okay. So why did one of the probes? Why did the data suggest that there's some huge electric charge around one of these comets?
Well, the one of the key missions was the 2005 mission to Comet Tempel 1, which was the Deep Impact mission. Now, what they did with the Deep Impact mission is they wanted to fire a projectile at the comet from a probe, and then film that projectile crash landing into the comet's nucleus and see what happened. And interestingly, as somebody pointed out to me when I was speaking about this, and I didn't really think about this initially, they actually fired a copper probe into the comet. And it makes you wonder why they chose copper as a material, which I think it was an 800-pound probe, and that's got to be very expensive to put £800 of copper. It's not. I mean, it's not beyond the realm of a space mission budget, of course, but it's still an expensive amount of copper, £800, to put into a probe to fire into the comet. Why was it copper? Why didn't they just use a lump of rock or something to see how the rock fragmented? But no, they chose copper. They probably had a reason for that. But what actually happened when they did that was, as this projectile approached the comet, and the projectile actually had a camera built into it, so they were able to film the approach to the comet, and they've got a time-lapse video of this, which is on their website, on NASA's website, and they basically saw a discharge, momentary discharge just before this probe impacted the surface of the comet, and the brilliance of the flash was probably 5, 6, 7, 8 times brighter, and all the NASA scientists were, wow, we didn't expect it to do that. This is much more energetic than we thought it would be. And also there was very little of a crater. There was hardly any crater. They claimed there was going to be a big crater, but there wasn't. Which, of course, if this thing was mainly snow and ice, an 800-pound copper thing travelling at, I forget the velocity, but it was several tens of thousands of miles an hour, would make quite a significant crater in a ball of ice. It would, because the heat from the impact would melt it, and all kinds of stuff would come flying out. That really wasn't seen, not to the degree that you'd expect. But the Electric Universe guys, particularly Wallace Thornhill, as the probe was approaching on the day that he knew that this mission was going to impact the comet, he made these predictions, and he lists them on his website, and they said that there would probably be not only an electrical discharge momentarily before the probe hit. He also said that the electronics from the probe would be experience interference because of the electrical charges.
Electric field.
Yeah, the electric field, exactly. And that's exactly what happened.
All right. Well, so if we've got a huge charged object flying through space at speed, that's what an electric current is. Something which has charge, which moves.
Right.
It is current.
Right.
So we've got kind of a current flowing through space then.
Right.
Really. So, and if that were to fly through a magnetic field, it will change its motion. If the sun emits high levels of radiation, which it does, would that affect something which is charged?
Well, I don't think the radiation would, but you make a good point about the electrical field and the magnetic field. The sun has a magnetic field, so
right.
I don't know. I've not studied the electric universe theory to see if there are small perturbations in the orbit which are actually a result of the interaction between the electric field of the comet and the magnetic field. I don't think. You may find that the effects are not as strong as that.
Right. And what about the actual tail? Or do the Electric Universe people say that the tail is due to an electric effect?
Yeah, the tail. Well, I think what they basically say is that obviously you're going to get some heating. Some of the effect does come from heating, but the fact that you don't have much water means that the way that the cloud is formed has to be explained in a different way. Mm-hmm. So the cloud is actually of the tail is formed probably by the electric fields of the object and the sun interacting, mm-hmm. where you get the solar wind, which is a stream of charged particles. Those charged particles hit the comet, and they will charge the field around the comet and cause various effects, one of which is the formation of the tail, and that field helps to keep the tail contained in a particular shape in most cases.
Right. So have they not examined the orientation of the tail to say, well, hang on, that can't be purely but the result of a Newtonian reaction, that it's travelling at speed that way, therefore the tail would be immediately behind it? Does the tail deviate? If you see what I mean?
Well, the tail can deviate because particularly this became particularly obvious with Hale-Bopp. I'm not sure if the Electric Universe guys have actually explained, for example, Comet Hale-Bopp. You can see that Comet Hale-Bopp has two tails, right. A gas tail and a dust tail. You can clearly see that if you go and look at the images. So it's quite possible that their explanation would involve the way that the electric field is formed around the comet, and that's what causes this.
Okay.
This.
Now I know that well, when I spoke to Lloyd Pye, he said that he was a fan of the electric universe theory. So why would it be that your average astronomer or cosmologist or physicist even maybe would reject the idea of forces due to electric effects in the formation of the solar system and the universe? What's the contention over it? Why is it such a hot potato?
Well, I'm not quite sure overall, but again, we could imagine that it's something to do with the way that we might derive energy,
Right.
because if the solar system is more energetic in the sense of an electric field and so on, it may raise questions about various energetic processes that are going on in the solar system and having to have a different explanation for them. So that could be part of it, but I think it may in this case just be down to laziness.
Right.
In other words, if you realise that many of the fundamental sort of equations that have been worked out are actually, they're only approximations and they're not accurate enough,
Right.
then you're going to have to rewrite a lot of the textbooks, and you're going to have to let go of a lot of the original research and replace it with something else.
Right. All right then, Andrew, we'll continue with the electric universe theory and comets after this. Welcome back. I'm talking to Andrew Johnson about comets, and we touched on the electric universe theory. Can you, because I still don't have my head around this electric universe theory, Andrew, can you give us in a nutshell, what is the electric universe theory?
In a nutshell, the electric universe theory says that electric force, electric fields, electric forces play a much greater role in the formation of structures we see in the universe when we look around,
Right.
than is now acknowledged. And David Talbot and Wallace Thornhill, who looked at this, they based this on observation, in that they've seen, for example, plasma formations when you use electrical discharge in combination with gases. Right, so you pass electrical discharge in various ways with various fields through chamber full of gas,
Yeah.
which is and then and you heat up the gas so it becomes plasma. And when you get the plasma is charged, so the charge within the plasma reacts to the electric field. It's influenced by the electric field, and they say that the plasma formations that you can create in the laboratory match, in many cases, large-scale structures in the cosmos.
Right.
Like there's the Helix galaxy, or the Helix formation, and the Hourglass Nebula, for example. These all look like plasma formations where you've got electric fields in certain orientations, which are then causing the gases to flow and produce certain shapes of clouds. And they've got many examples of this.
So let me just interrupt that, Andrew. So are they saying that your standard astronomers and cosmologists, they've got it completely wrong? Is that what they're saying?
Yeah, well, I don't know if they say they've got it completely wrong, but they're saying that they make one of the basic points that they make, for example, is that if you look at the electromagnetic force, it's something like 10 to the 24 or 10 to the 34 times more powerful than the gravitational force.
Right.
So how is it that such a weak force, according to standard theory, can give us most of the form and shape in the universe,
Right.
when the stronger force, the electric force, is not giving us anything at all, according to the standard theory? That's one of their basic observations.
Okay, Andrew. Well, I don't think we're going to solve how the solar system was formed just in this conversation. It's a huge question. But let's go on to look now at some of the craters on Earth that still exist from comets which have impacted, because this is another area that's been used to create fear, perhaps,
Exactly.
in films like Deep Impact and things like that. So what's the likelihood that a disaster could occur?
Well, I mean, yeah, let's talk about that, because that's again one of the reasons why I put this presentation together, because every time we get a comet comes into the news, as was with Hale-Bopp and Comet Elenin that we mentioned, we'll probably talk a little bit more about that later. Comet Elenin was in 2011. you go onto the internet and you'll get many websites saying, oh, the comet's going to crash into the Earth, it's the end, stock up with water, buy your water filters, buy this, buy that, buy your radiation suit, etc. And so that's comets are really good for generating fear, as you already said. So but it is true in that if you go around the Earth, and I wasn't sure of this until recently, on the surface of the Earth have now been determined that there are 184 impact craters, and some of them are quite big. Some are several miles across.
Right.
The really, I think the most famous one, which the first one I ever heard about when I was a kid, is Meteor Crater in Arizona, and that's got a tourist centre next to it, and it's about a mile across. It's 500 feet deep. I think it's 50,000 years old. I think it's relatively recent, and it has to be because the surface of the Earth, it's still there, because obviously the surface of the Earth gets weathered, it gets eroded, the climate changes, and so on.
So these are all relatively young impact craters because they're still there.
Well, most of them are relatively young. I mean, again, the ages vary, but I think you can see the ones that are more weathered are the ones which are older, obviously, and more eroded. So some of them are covered up, and the oldest one they found is in the Yucatan, which is the land has kind of moved over it, and the land has reformed, and that was the one that was allegedly where the impact that wiped out the dinosaurs was, and that was I think 65 million years ago.
So it is possible that we could be hit by something which could affect life on Earth, then, you think?
Oh, absolutely, and in fact it's already happened. I mean, earlier this year in February 2013 we had the impact over Chelyabinsk, or rather not an impact, it was an airburst over Chelyabinsk. That was a reasonable sized object. Several thousand people were injured because of flying glass. Windows were blown in, and there was a factory wall fell down. So that was some quite significant damage, and it was across a relatively wide area. And the one which I put into this presentation when I was asked to give this was the Tunguska event, which happened in 1908, and they're still not quite sure what that was, but it was flattened an area of about 200 square miles of forest. Well, some authors have suggested that was not natural. Right, they've said, suggested various things: a nuclear bomb, Tesla's beam weapon, an exploding flying saucer or something.
Yeah. Well, and then you also mentioned in your presentation the alleged comet of 562 AD, which Alan Wilson is quite keen to talk about. Right, and of course Alan would probably do a much better job of talking about that than I would. But the thing that intrigued me was the vitrified hill forts that I think you were going to go and film there, weren't you, at one time? We were. And I'm quite curious about that, because there was also I came across a report from Italy of an impact in Italy, and that was dated also to about 500 AD or 560 AD. Yeah. So it appears there is a significant amount of evidence for some type of catastrophe, of reasonable sized catastrophe. And as I think Alan Wilson said, England was uninhabitable for about 7 or 11 years. Yeah, so that's what Alan claims, and he claims that helped end one of the, you might call it the true British reign, of the original British, and the Saxons then came along and effectively just walked into an empty country, and it wasn't taken by force, as is suggested in the history books, for example. So, a hugely contentious issue, but that's Alan, puts a lot of. He thinks that event was extremely important in changing the direction of British history in 562 AD. Right, and of course I'd add on to that time, as I understand it, was called the Dark Ages, and indeed that's what it would have been. Yeah. All right. Well, just to mention that there is actually something they call it the Space Guard Centre, and that's in Knighton in central Wales, or it's in mid Wales. It's on the border, England-Wales, and that was put up in the 90s, and I've been there. I've got some film footage of this, and its job, allegedly, is to look for near-Earth objects. They've got a couple of domes there with telescopes in them and what have you. But I know a researcher who thinks that it's actually a cover, and that it's not looking for near-Earth objects. I don't know this to be true. This is
It's looking for near-Earth objects, but not rocks.
it's looking for near-Earth objects, but they're actually on the Earth.
Right.
Yeah, animal mutilation cases,
Right.
possibly. I mean, we don't know that, but it seems that there is a military connection with this Space Guard Centre, in that the person who managed to get permission and funding to build it is ex-military. So I went there, and there's a very interesting stone circle which was put there in 1997 called the Diana Circle, obviously after the death of Diana. It's a stone circle, 24 stones I think, and in the centre is a huge silver like chrome ball.
Wow.
Fixed to the ground with a chain. Now what that's for I don't know, but to me, are they really looking for near-Earth objects at that place, trying to save the planet? Possibly, but possibly not, in my opinion.
No, I mean, I think spaceborne systems would be far more effective in doing that these days.
Mm-hmm. And a lot of these objects seem to get discovered by relatively amateur astronomers.
Correct.
So can you tell us about that, Andrew? Because this applies with the ISON comet. We just want to.
That's correct. Yes, I mean it's very important to understand the role of amateurs, because you know you and I have spoken at length about how NASA has covered things up, and I think they're covering a lot of stuff up.
Mm-hmm.
But
just to interject there, Andrew, one thing that you can't cover up is the sky.
Yes, I mean that's right. You can't cover up people's own observations of the sky, but of course many people hardly even look at the sky. So if you go around telling them what's in the sky, and they never bother to look for themselves, then you can create a false impression of what's there or what isn't there.
Yeah. So ISON, is there any points you want to make about that before we come on to Planet X?
Right. Well, yeah. Well, Comet ISON, I mean, is a prime example, because that was discovered by two amateur astronomers. The thing partly why I went through the explanation of the size and scale of things in the solar system is because of the way that comets are discovered by amateurs, and you've got some quite advanced equipment now. Comet ISON was discovered in September 2012 by two Russian astronomers. Now they were working as part of an organised group, a well-equipped group of amateurs.
So that's about a year before it got anywhere near Earth.
Yes, correct. It was about a year before it was close to us, and they discovered it with a relatively small telescope. I think it was about roughly 1 meter telescope.
So interject again, Andrew. So can I take it from that then? If there is going to be a reasonably big object which is going to affect the Earth and hit the Earth, someone's going to find it first. With a lot of warning.
That is precisely my point. Now, if you go onto that Minor Planet Centre, you'll see that they get thousands of observations logged on there per month. There are many amateurs around the planet in competition with each other looking for these comets, and we have to mention how the size of Comet ISON when it was discovered. When Comet ISON was discovered, it didn't have a really great tail behind it. It was a little tiny blob on a photograph. We've got an image of the discovery of how they discovered it. Right. They saw this little tiny dot on their image move, from one place to another on their image, a distance of, maybe 20 or 50 pixels on their digital image, and that was taken 30 minutes apart. So they knew it was moving at speed. And that object is 2 miles across, and it's out beyond the orbit of Jupiter when they discovered it.
And it was spotted by amateurs first.
And it was spotted by amateurs first.
So there you go.
And they're doing it all the time. They have special telescopes which are computer programmed. They track portions of the sky. They put in